I'm really excited to have a conversation today with Alex Shaw.
Competitions are a really good way to incentivize people to work on a shared problem and produce interesting solutions.
That's one of the amazing things about being on the Kaggle competitions team is we get to touch so many different interesting projects to see the community come together with all sorts of things you would have never thought of.
Hey, I'm Meg Risdal, and I'm really excited to have a conversation today with Alex Shaw. He is a member of technical staff at the Laude Institute, co-creator of SWE-Bench, and creator of the Harbor Agentic Evaluation Framework. And I'm also joined here today by Walter Reade, a technical lead on the Kaggle competitions team. Walter, you know Alex personally.
I have known Alex for a long time. So fun fact, Alex's father and I were in grad school together at Penn State. Our families have kept in touch ever since. So I have known Alex for a very, very long time and super excited to interview. So why don't you tell us about your education, how you got started, how you ended up in tech?
I knew I loved technology. I'd always watch the Google I/O events and try to try out the new latest Android features and Android phones and stuff like that. So I first picked electrical engineering because I just saw that, and that was the only major I knew that for sure had something to do with technology. And then I asked my trusted mentor, Walter Reade, what he thought I should study. And Walter said, just go and pick whatever major is going to let you do machine learning. So I switched from electrical engineering into applied math, and that's what I ended up studying. And that was kind of my path into machine learning, and then eventually AI, deep learning, benchmarking, et cetera. So I guess I owe Walter a lot.
I mean, I'd love to take credit, but to be fair, I badgered everybody to participate on Kaggle and to go into machine learning. So you did a master's, and you also did two internships?
Yeah, I did an internship at Apple, and then I did an internship at Google. So I interned on this team called Conversion Lift, and what Conversion Lift does is they try to measure the effect of ads, and then we would approximate the standard error of our lift estimate. That way we could tell people this is a statistically significant bump in spend that you're seeing because you're running ads on Google Ads. But I think 2 or 3 days in, I was trying to understand the method, so I just ran a bunch of simulations and came to realize that it was going to give us a better estimate of the standard error, but it wasn't actually going to shrink the standard error itself. So I told my intern host and then my manager, and then the skip manager sent it to a data science team, and then the data science team confirmed my findings. So then that project kind of got deprioritized, and they put me on a different project that was higher priority. They were super cool about it. My skip manager sat me down and he said, if you have conviction that something is right, then this is a place where you should bring that up, and we'll recalibrate based on that.
Now, this is where Alex's story intersects with Kaggle a little bit. So you were working on the ads team, and then you actually contacted me because you wanted to connect me with one of your contacts to talk about a competition related to SWE-Bench. You want to talk a little bit about SWE-Bench, the competition, and kind of how that thing came together?
My friend's name is Chris Ritting, and he was a PhD student when I was doing my master's, so that's how we knew each other. And we had kept in touch because we were good friends. And at some point he told me hey, I met this guy, and he's super tall and he has a huge beard, and his name is Andy Konwinski. Andy co-founded Databricks and Perplexity. And he met Chris at this random event. I think he was giving a presentation at the University of Washington, and him and Chris kind of hit it off. And Andy shared this crazy idea that he had been cooking on of this new institute that he wanted to create, and kind of the way he wanted to convene a team to start this institute was to do this thing called the Konwinski Prize, which was a $1 million prize around SWE-Bench. And he kind of commissioned Chris to go and make the K Prize happen. And Chris was telling me about this on the phone, and I heard the word competition and machine learning, AI, and prize, and I immediately thought of Walter. So then I told Chris, I said, well, you should talk to Walter, because this is literally what Walter does for his career, is helps people launch these types of competitions.
Do you want to talk a little bit about why the SWE-Bench and the Konwinski Prize was kind of important in the space? What role does it fill? Why do we even care?
SWE-Bench was created in 2023 or 2024. It was really impressive foresight from those two researchers, John Yang and Carlos Jimenez. And they created this benchmark, and they took a bunch of pull requests from GitHub that, as part of their pull request, one, resolved a GitHub issue, and two, included some unit tests to test whether their implementation did resolve the issue. And then they kind of remapped that into a problem that you could give a language model with the starting state of the repo before the pull request was made. And then they test the agent's implementation against the unit tests that the actual pull request created. And it's just a really clever and effective way of measuring whether AI agents, and at the time mostly just like LLMs, could generate code that would like resolve GitHub issues.
Do you want to talk a little bit about the difficulty in having a real competition that where people aren't able to cheat, or where it's a meaningful measurement in some of the challenges with the Konwinski Prize?
I just think it's extremely difficult to make, I think, a robust and secure competition. And then there's also a lot of other variables that get introduced, like how do you handle internet access? How do you handle model endpoints? Do you do open source only or closed source? And I think you guys helped walk us through a lot of those hoops and make the correct decisions. What we ended up doing was we scraped a bunch of GitHub PRs and turned them into SWE-Bench tasks. And then we provided that as kind of like sample data to the competitors. And then the competitors spent 3 months creating agents and training models that they submitted to the competition. And then we waited another 3 months for new GitHub PRs to get created. And then we scraped those and turned those into the final test set. And that idea, I think, came from you guys at Kaggle, because you were able to map our competition kind of onto these stock trading competitions that you guys had seen previously. And even the idea of kind of doing this as like back testing and giving us some time to gather up new data, I think helped us build a more rigorous competition.
Amazing. And do you want to talk a little bit about the K Prize? What did you learn? Did you feel like it was significant?
The competition itself, I think it definitely accomplished its purpose in the sense that like we got it and people competed. It was really interesting to see like the creativity of the contestants. I mean, the two first and second place people had these like really intricate agent designs that I wasn't expecting, and they had like fine-tuned their model on all this like data that they had scraped, and they had all these like checks in place to make sure that it was like not going off and doing some crazy thing. So yeah, it was cool.
What do you think is like the value of knowing or seeing what the state of the art is under the kinds of constraints that were placed on the K Prize?
One of the things the K Prize sought to do was to incentivize people that like, this is an important problem. You have to remember, Cursor was just getting popular. This was pre-Claude Code. This was pre-Codex, like these things. So it was trying to incentivize people that this is an interesting and important problem to work on. And then second, it was, what do these models actually score when there's no contamination? And it was like guaranteed no contamination, because there was like an actual time barrier in place. And I think that it kind of recalibrated my expectations a little bit as to like where the field was at that time. And even now, I think this is a problem I'm still interested in and we're trying to solve, but from a different angle, which is by building Harbor, this evaluation framework and RL environment framework. We're giving people the tools to create benchmarks quickly and to create lots of them. And that's kind of also hopefully addressing this problem of overfitting to like contaminated benchmarks.
What did you learn pulling all of those kind of different issues together? And how did that kind of change your thinking about what was missing from the industry?
I think this kind of leads into Terminal Bench, actually, because the place where we decided to start working on Terminal Bench with Ludwig Schmidt was at Internships after the K Prize announcement. So I think Ludwig and Andy had met each other a while ago, and then Mike Merrill, who was a co-creator of Terminal Bench, was also a friend of Chris's from the University of Washington. And I think all of us were kind of seeing similar things from different perspectives. So I had just spent months in the SWE-Bench code base. There was some abstractions that became clear after spending a lot of time looking at these tasks that, why does a task have to be a GitHub repo? Why does it have to be a code base at all? There's lots of things that you might want an agent to do on a computer that are not necessarily just creating GitHub pull requests. Around that same time, I think Ludwig, what he says is he was asking himself like, oh, when are the agents going to replace me? And kind of going down this thought train, he started thinking to himself like, well, a lot of the technical work I do takes place in the terminal. So I think the terminal would be a really powerful tool that agents could get good at. And then Andy has a knack for being extremely early on trends, actually. But like a year earlier, he had decided he was going to build this project that he was calling HT, which is headless terminal. And his whole idea was just like the terminal is a really powerful tool to give an agent. The more abstract formulation of a task and the idea that the terminal is a powerful tool that agents can accomplish arbitrary things on a computer with, and then merge those two together into, at the time, SWE-Bench, which then later became Terminal Bench, and started building a benchmark.
Can you go deeper on sort of like what gaps a benchmark like Terminal Bench fills, and why that's important?
There has to be a capability that you care about or you think the field is going to care about, but maybe it's not quite super important yet, so nobody's actually built a benchmark to measure it. And for us, that was the terminal, right? We decided that the terminal was a powerful tool. There wasn't an existing benchmark that directly attempted to measure it in a way that took advantage of all the different types of things that you could do with the terminal. You have to make it usable, right? Like it has to be adoptable, and people have to feel like there's like a reasonable amount of friction that they're willing to put themselves through in order to use the benchmark. And then I think it has to be high quality. So the benchmark itself needs to be implemented well, right? Like it needs to be robust. The verifiers need to be resistant to reward hacking, all of these types of things. The tasks need to be representative of the distribution you care about.
One of the design decisions of Terminal Bench is a pass-fail binary evaluation.
Part of that was actually informed by the Kaggle competition. And maybe that was the only learning that we had that wasn't exclusively positive from the Kaggle competition. So it just got kind of complicated, and the leaderboard just didn't feel as meaningful. We wanted you to look at the score you got and instantly have some intuition what it means. And I just think the simplest is like pass fail % tasks resolved.
Another aspect of the design of Terminal Bench that I really like is that it's effectively crowdsourced. It sounds like you basically nerd-sniped your friends into contributing to Terminal Bench. Like, tell us more about how that worked.
Well, first of all, I would say that task creation is a surprisingly nerd-snipeable problem. So what you do is you just start talking to people, and first you tell them like, hey, would you be interested in contributing tasks to my benchmark? And nobody is excited about the prospect of that. Like, that's not exciting. But then what you do is you ask them, what's a hard problem that you had to solve recently? And like, how do you think you would formulate that in a way that is verifiable? And actually people, what you'll notice is they always have like 2 or 3 things that they come up with, and then they start to get excited about it, and they actually want to see like, I wonder if the agent can actually do that. If it's easy to create a task, if it's easy enough, then they'll actually go and implement it and then submit the task. You also need other incentives, I guess, like curiosity can't be the only incentive. So we also published a paper around Terminal Bench, and a lot of our contributors were academics. And it was actually Mike Merrill, my co-creator of Terminal Bench, came up with this point system where like if you created a task, you get like 2 points. And then if you reviewed someone else's task, you get like 0.5 points or something. And then that determined like the ranking of the authorship on the paper. So yeah, we probably had like 250 contributions, and then we did a massive QA process, and like 89 of them actually became tasks in the benchmark.
Right now, we're in like this era where benchmarks are constantly becoming saturated. And what do you do in the design of Terminal Bench to mitigate against saturation?
The way to address it is just to make it easy for other people to create benchmarks. And the most important thing is that benchmarks are being created in the category of tasks that people care about automating. And if you put benchmark creation tools like Harbor into people's hands, then they don't have to try to make a benchmark someone else cares about. They can just make a benchmark they care about, and they want it to be saturated, right? Like they're trying to do everything they can to saturate that benchmark. So yeah.
Now I want to talk a little bit about like agent scaffolding versus the model's capabilities on its own on Terminal Bench. What is Terminal Bench actually measuring? What are your opinions about choice of scaffold?
It is very interesting to see how a model performs in a range of harnesses. And it definitely seems to make a difference, right? Like if the set of tools you choose to give, the way you implement memory, the prompts, the context, the way that it manages context, all of that seems to really stack up to like pretty substantial gains. So I think you sometimes see spreads of like 20% or something on the benchmark. And that's just what the benchmark is able to capture, right? Like that's not even really zooming in on one specific type of task and seeing if you can really optimize that in a harness. It's important that your harness is sufficient. And what I mean by that is it's capable. It like gives your model the affordances that it needs to be able to complete the tasks. But other than that, Claude Mythos reported like 80-something% using Terminus, and previously like that was the best you could score with like a custom harness. So it's kind of just showing that like the models do seem to eat the harnesses eventually, but there's always like a marginal gain to get out of optimizing your harness.
It sounds like this is part of the inspiration for the Harbor agent framework. Can you talk a little bit about why you created Harbor, what gap that is filling?
The overarching idea is just like give people tools to measure and understand and improve their agents. And then anything that kind of is relevant to that, I think falls under the idea of Harbor, like the concept of Harbor. There was a tweet the other day actually from Francois Chalet, who a former Googler, I think, and created Keras and Arc AGI Prize. And it was a really interesting tweet. He said, now that programming is mostly being done by coding agents, that means software engineering is now more of a machine learning problem than a software engineering problem. Which means you're gonna need some of the same tools that you use for machine learning, and you're gonna also have some of the same pitfalls that you see in machine learning. So you'll see things like overfitting, right? Like this is like reward hacking and stuff like that. And you'll want to tune your hyperparameters, which in this case maybe is like tools and context and memory. And you'll want to do ablations. You'll want to have a test set and a train set and all of these things. I think Harbor is just kind of trying to be those things, right? It's like trying to be the toolbox, the toolkit that you need to really understand and optimize your agent. So there's Harbor format, which is a simple format for defining these types of tasks that you might do on a computer that you want to see if an agent can do. And then there's Harbor framework, which is essentially just a way to do rollouts on these tasks with a bunch of like pre-integrated agents and sandboxes. And then there's Harbor registry, which is a registry that lets you distribute your benchmarks through the Harbor CLI.
And it sounds like part of the inspiration was putting open source tools out there in the community and seeing them do really interesting, crazy, weird things with them. I'm curious if there's like any examples of things you've seen in terms of like what the community has been building using Harbor.
Maybe one of the emergent use cases that is interesting is we mostly built Harbor just to be useful, but we didn't intentionally try to make it like a standard, but it seems to have emerged to be that for a lot of the data space, I think. So like a lot of data creation companies will create Harbor style data and then sell those to Frontier Labs and Neo Labs. And they all kind of like it because there's like this many-to-many relationship, and it solves this coordination problem where there's like an agreed upon format that's like extremely flexible, but also extremely portable. So I think that's just like the nature of an industry where data is passing between many hands, like incentivizes a standard, I guess. So that was kind of a cool thing we saw.
What's the value of standardization versus, in this case, like letting 1,000 flowers bloom and seeing the kind of innovation? Like, what is the value of that?
The obvious pro is when you solve a coordination problem, you're just increasing velocity. So in this case, the models are mostly driven by data, but for the most part, like a lot of the parameters are fixed, and it's mostly just like the data recipes and the data curation that's really driving a lot of the performance gains. So in this case, like data is extremely important, and therefore data velocity, your ability to get new data, your ability to like plug it into your systems and start testing it and figure out if it's going to work for you is super important, both as an agent developer and as a model developer. So the benefit of being able to move quickly with data is very large in the data space. So I think I'm happy that Harbor is able to solve that problem. The only risk would be if it places a constraint on the industry. So we try to be extremely thoughtful in how we extend the format. We try to extend it in ways that lets you do interesting types of things. Like we just released multi-step tasks. People ask us a lot about like simulating users and stuff like that. So yeah, we're spending a lot of time thinking about how we can make this as useful as possible for people. And I would say in general, like the capability you want to measure should drive everything. So if that doesn't fit within existing paradigms, then you should just make a new framework. But I think probably 99% of them do fall within Harbor. So then you should go take advantage of that and get value out of it and move faster.
I want to go back to your career. So you made a bet on Andy Konwinski, and you're like, I'm going to do this for 3 months and see how this plays out. You talked about a very high variance possible outcomes. Where you've landed is now you're full-time member of technical staff at the Laude Institute. Tell us more about the Laude Institute and what your day-to-day looks like.
I'm more honored that he was willing to take a bet on me, honestly. And that's one of the best aspects of working with Andy is he's extremely meritocratic and he doesn't care really that much like about background or prior work. He only cares like how are you actually doing? Are you solving interesting problems and are you capturing the world's attention? I joined Laude after we launched the K Prize and then immediately just started spending most of my time working on Terminal Bench. And I remember Andy came to me early in Terminal Bench and he was like, this is an important project, so I want you to capture the world's attention with it. None of my other bosses ever asked me to do something like that before. I felt like that was a big responsibility. And then I was talking to like one of the PhD students who was tangentially involved in the project. And I was like, hey, do you think like we'll be able to make this project as popular as like Open Hands or something? I think Open Hands was the comparison I made just because it was popular at the time. It was like, it's like a popular open source coding agent. And he was like, no, I don't think so. And I was like, okay, well, we have to try because I told Andy that we would. And then, you know, we put a lot of effort in, we tried to execute really well. And I think we actually did capture the world's attention with Terminal Bench and then again with Harbor. So very important to surround yourself with people who believe in you and who push you to take big swings at important problems. So, I mean, we're going to take bigger swings over the coming months and years. I mean, I have a lot of flexibility, so I kind of just decide what the most important problem is to work on this day. And then I move to the next thing. And maybe sometimes that's like, we have these hard technical problems, so then I'm coding, or I guess I'm telling Claude or Codex to code for me, or Gemini CLI.
At Laude, you have this thing called Slingshots and Moonshots. I'd love to hear more about what is the Slingshot Moonshot program? What are some of the cool slingshots that you've seen?
Andy started Laude Institute to accelerate impact research, and he defines impact research as research that doesn't stop at the paper. There's this inefficiency that exists in the world, which is good ideas that die in papers, and if you would just go far enough to put them into real users' hands who are experiencing that problem, there's a lot of value to gain there. And then I guess just in general, like anytime there's an inefficiency in a market, that's an opportunity to create value. Part of the way that Laude does that is by funding these slingshots, funding these moonshots. Moonshots are like larger lab-sized bets where people are going to spend multiple years working on an extremely ambitious and important problem. And then the slingshots are like smaller scoped projects that maybe a PhD student or a really ambitious person will go and apply for and get some amount of funding or some amount of support in some other way and start working on that. So JEPA, if people have heard of that, the prompt optimization method, ArcAGI was actually a slingshot. A student from Berkeley just put out a benchmark called the continual learning benchmark. And I think that's really interesting. It measures how well agents actually benefit from the prior work that they perform and if it is able to like improve their performance on tasks that come later. So yeah, those are interesting ones.
Yeah, that's very cool. For anybody who's watching, who's looking at the Slingshot program or the Moonshot program, how would you connect that to Kaggle and opportunities to work on Kaggle competitions?
Competitions are a really good way to incentivize people to work on a shared problem and produce interesting solutions that are often benefit people more than just the recipient of the prize. If people have a problem they want to work on and they think that it would be addressed well in the form of a prize, then they should consider if they want to apply for a slingshot, and as part of that slingshot, ask if they can run their competition on Kaggle. I think that would be a good idea.
That's one of the amazing things about being on the Kaggle competitions team is we get to touch so many different interesting projects, and it's like so gratifying and amazing to see the community come together with all sorts of things you would have never thought of. But when you have 2,000 people across the globe putting their collective brain on something, it just, you get a really good solution.
All right, I'd like to zoom out now. If you could wave a wand and create any one benchmark, what would you create, or what would you like to see someone create?
I want to create a benchmark that's called like best practices bench or something like that. And it's like intentionally under specifying tasks to see if the agents implement them in a way that includes best practices. So what I mean by that is like, if I ask the agent to create a database function for me or a SQL query. I want it to be fast and I want it to be safe and secure. And I don't want to have to tell it that every time. That's just obvious. Like any good engineer knows that they should always care about speed. They should always care about security.
I love that because I can't tell how many times I've written code, works great. And I said, yeah, actually, would you mind using more than one core when you run this? Right. Oh yeah. Okay. I'll use all your cores.
Exactly.
So, yeah.
How does Kaggle harness the energy of its community and direct it towards building better benchmarks for the industry?
To shamelessly plug, like we're working on Terminal Bench 3. So if Kagglers want to get involved in Terminal Bench 3 and contribute a task to it, I think people should just be experimenting and they should be trying to, participate in all sorts and anything that they think is interesting. Andy gave the UC Berkeley graduation speech last year, and I think he said, it's very important that you do things with your team. And he says, you have a team, right? Well, if you don't, then get one. There's teams on Kaggle, and it's a place where you can meet people. But in general, it's like, I don't think you have to do these things by yourself.
Cool. Well, thank you so much, Alex, for spending some time with us in conversation with Kaggle, myself, and Walter. And thank you for everybody watching, and we'll see you at the next one.